So, are you ready? I'm Ashlee Bartlett. I'm a junior chem major here at Spring Arbor. So this summer I was at Mississippi State University doing an REU. My research this summer was based on transition metals and how they work as catalysts for olefin aziridination and cyclopropionation. So first I'm going to tell you a little bit about what the REU is. So the REU, it prepares students for graduate school, which is really important if you plan to go to graduate school, because before the summer I had no idea what to even expect going into it. So we got hands-on lab experience, which was really cool, because if you know me, you know I love being in the lab, and I spent so much time there this summer, and it was absolutely wonderful. So it also helps students network, which I'll talk about a little bit later, and it also teaches students how to write manuscripts, which is a lot harder than you might think. So getting accepted into a program. If you get rejected at first, don't worry. I applied to 22 different programs, and before I got accepted to any, I got rejected to 16. I got rejected to a total of 17, didn't get a response from 2, got waitlisted on 1, and got into 2. So if you don't get accepted right away, don't freak out, it's not the end of the world. So networking. REUs are great ways to meet people that will help you with your future career, whether it's your PI or your grad student or other people in your lab or other people in the REU even. It helps you know people all around the country. So that's really cool. So activities. We did a lot of different things while I was there. One of the things that I really enjoyed was we got exposure to another graduate program. We went to University of Alabama to present what we were doing, and we got to tour the facilities, meet the graduate coordinator, meet a bunch of grad students, and just talk to them and find out what it was like on their campus. We also got to attend lab group meetings and present at lab group meetings, which was a little bit intimidating because they were treating us like the rest of the grad students. So that was quite interesting. We also had weekly lunch seminars about grad school, so how to apply, how to what to look for when you're applying, and things like that. We also had seminars about different career pathways, whether it's academia, industry, or in a national lab or something like that. And the last thing we did is we had an undergraduate research symposium, so we got to present what we had been working on all summer. So now I'm going to get into the training. In order to work in a lab, you have to be trained. So this summer I was trained on rotary evaporation, which doesn't seem like it's too hard because we have one upstairs, but theirs is really fancy and I didn't know how to use it. So yeah, it was quite interesting just learning how to use all the different equipment. I also did a lot of prep TLC, which is like regular TLC, but 10 times worse because it's a lot bigger, so it takes a lot longer. So I learned how to do that, and I did probably 50 different prep TLCs all summer. I also learned how to do X-ray crystallography and use an NMR. So running reactions. I did a lot of synthesizing, as you can see by my first picture here. All of those, the first word is synthesis. That's only the first page of my table of contents. I ran about 130 reactions this summer, so I had that 130 times in my lab book. So all of our reactions that we ran, we would extract and purify. So take 130, multiply that by 4, that's how many steps I did this summer. So now I'm going to get into the chemistry that I worked with. So the biggest thing I did was synthesizing aziridines. So to synthesize aziridines, you need to use an alkene derivative, so either a styrene derivative or a different type of alkene derivative, and a nitrogen transfer source. We used FINTs, and we ran these reactions both in the presence of DNA and then without the presence of DNA. So these are the different catalysts that I was personally working with. So we have the first one, which is copper fen, second is copper dioxofen, and the third is copper DHOP, the fourth being silver fen, which is what I did a lot of work with. So this is some of my data that I collected. We have the substrate scope and catalyst loading studies for the aziridines. This is with the first catalyst, the copper fen. So as you can see, for the first section, we have the different catalyst loadings, and they all had really high % yields. And then for the second set is all of our styrene derivatives, and the last set is all of our different alkene derivatives. And all of our % yields were really high, and this is without the presence of DNA. So with the presence of DNA, all of our percent yields were relatively the same as what they were without DNA, which you might be wondering, what does the DNA do? What we were trying to do is make the aziridine enantioselective. So, and if you don't know what an enantiomer is, it's basically the mirror image of something else. So we were trying to see if we could make it favor one mirror image over the other mirror image. So why is this important? Aziridines and cyclopropanes are found in a lot of medicinally active compounds and found in a lot of polymers. So they're everywhere. These are just some examples of the different types of medicines they're found in. So this one, there's a cyclopropane in an antifungal. This one has an aziridine in an anti-tumor medicine. And this one is an anti-HIV and it also has a cyclopropane. So these are just a bunch of different examples of where you can find the cyclopropanes and aziridines. So trisphene copper 1 triflate. I accidentally discovered this molecule while I was there. It was the side product of one of my cyclopropanation reactions. So we rotobaped it down and then we put it in diethyl ether so we could do gas chromatography of it. And then all of a sudden we were looking at it, and if you look really closely you can see that there's little black dots in the bottom of that vial. And those are little crystals. We're like, what the heck are these things? So we took them down to the X-ray room and did some X-ray crystallography of it and found out that it was this. Copper with 3 phenanthralenes bound to it. And it's a copper 1, and we know that because there's only one counter triflate ion. So there's only been 4 recorded octahedral copper 1 complexes in the world, and I accidentally discovered a 5th. We haven't yet been able to directly synthesize the compound. It's only been able to be produced as a side product. So hopefully, eventually, we'll be able to figure out how to directly go to the copper, the trisphene copper 1 triflate. So, and you should go on an REU because it's a lot of fun. Like, I got to be in the lab every day, and I got to meet a lot of cool people, and sometimes we found random cats and brought them into the lab. They just were on the side of the road or in someone's car bumper, and yeah, we had cats. And then one day we got evacuated from the chemistry building because someone accidentally blew up an oven. That was a fun day. Yeah. So I just wanted to give a special thanks to Spring Arbor for getting me to where I'm at, to Mississippi State University for hosting the REU, the National Science Foundation for funding it, Dr. Emerson, Dr. Vai, Wesley, Harrison, Dylan Russell, and all my other lab mates this summer for helping me get through everything. And these are my references, so.